I'm going to read this problem and identify what is given to me and what is it the problem asking for me to find. So an 80 kilogram hiker, so I'm immediately thinking, okay, so let's name this as the mass of the hiker, H, is trapped on a mountain ledge following a storm. A helicopter rescues the hiker by hovering above him and lowering a cable to him. The mass of the cable is 8 kilograms, so I'm going to call this mass of the cable. And its length is 15 meters, so this is the length. A sling of mass 70 kilogram. Okay, so this I'm going to name it as a mass of a sling, is attached to the end of the cable. The hiker attaches himself to the sling, and the helicopter then accelerates upwards. Terrified by hanging from the cable in midair, the hiker tries to signal the pilot by sending transverse pulses up the cable. Pulse takes 0.25 seconds, so this is the time to travel the length of the cable. What is the acceleration? Okay, so we're looking for the acceleration of the cable, of the helicopter. Assume the tension in the cable is uniform. Now let's organize our givens and unknowns, knowns and unknowns. So I'm going to write in a nicer list. Mass of the hiker equals 80 kilograms. Mass of the cable equals 8 kilograms. Mass of the, actually the length of the cable equals 15 meters. And then mass of the sling equals 70 kilograms. So we know the pulse takes 0.25 seconds to travel the length of the cable. What is the acceleration? So what is the acceleration? That's a question mark. Now, I don't need the words anymore, so I'm gonna make some space for me and then start thinking, what do I know about acceleration? How can I solve? So from mechanics, dynamics, we'll remember that acceleration, or Newton's second law, says if there are external forces acting on an object, then there is an acceleration. So if we find out, because the helicopter accelerates, so our hiker also accelerates. So if we can find all the forces that accelerate the hiker, we might be able to apply Newton's second law and find the acceleration. So that's why I'm going to draw the hiker's free body diagram. So let's see what are the forces that act on a hiker. So we have the weight of the hiker and the sling. So I'm going to call it the mass, the total mass times G, downwards, where the mass is the mass of the hiker plus mass of the sling. Okay. And then there is another force. It's the tension of the cable. So tension of the cable, I'm going to call it force of tension, because I don't want to call it T, because when we talk about pulses and waves, T is occupied for the period. So that's why I'm using force of tension as a F. Now, then I can say the problem said the helicopter accelerates upwards, so the acceleration is upwards. So if I write sum of the forces, Newton's second law, equals mass times acceleration, and then write what is the sum of the forces, we can, well, first of all, let's choose the positive and negative direction. So suppose this is positive y, going downwards is negative y. Then we will have force of tension minus mg should equal ma. Well, voila, we can find the a from here. Acceleration equals force of tension minus mg over m. Well, now you would say, yeah, that was easy, but how do we find the force of tension? That's a question. Yes. Now, our new task is to find the force of tension. Okay, so we know that there is a pulse going on, and we have learned that that pulse will have a speed that is actually related to the tension of the cord or the cable. So, and we know that the speed of the pulse would be square root of force of tension divided by the linear mass density mu. So I'm thinking maybe from here we can find a force of tension that would be v squared times mu. Now you would say, okay, now we have to find the v, and we have to find the v, the speed, and the mu. Okay, well, the finding mu is actually quite easy. We're going to use the definition of the linear mass density, which is a mass of the cable divided by the length of the cable. So we can plug it into, well, we can plug the numbers into this expression, which is a 8.0 kilogram divided by the length is 15 meters, and then we can get the value for that. Now, to find the velocity, the speed actually would be speed equals, again, the definition, that would be the distance over the time. Okay, so we know that the distance that the pulse is moving is 15 meters across the entire length of the cable, and the time it takes to go through the length of the cable, it's 0.25 seconds, which gives us 60 meters per second. Now I can plug this one into my expression for force of tension, and then we will get force of tension equals 60 meters per second squared times 80.0 kilograms over 15 meters, and I forgot to put meters in here. And then we will plug this into the calculator, and we will get that equals 1.92 times 10 to the 3 newtons. Now all we need to do is to plug in the value of the force of tension into the expression for the acceleration that we have found, and that would be equals acceleration equals force of tension, which is 1.92 times 10 to the 3 newtons. What I'm doing, I'm plugging this one into right here. Okay, and then minus, okay, so we probably need to go back and plug in the values for the mass. So this equals mass of the hiker, we had 80 kilograms, mass of the sling is 70, so 80 kilograms plus 70 kilograms, which equals 150 kilograms. I'm rushing and I'm forgetting letters. Okay, so then I can plug it in. So 150 kilograms times 9.8 meters per second squared divided by 150 kilograms. So this needs to be plugged in into a calculator. which shows me that it's a 3.0 times meters per second squared. This would be my acceleration. Thank you for watching.